In this video, we're going to talk about solving quadratic equations by factoring. Okay, so what is a quadratic equation? This is ax squared plus bx plus c. Equation has an equal sign equal to 0. Okay, now a, b, and c are real numbers. And I'm going to say a is not equal to 0. If a equals 0, that means that first term would go away, right? And then it wouldn't be a quadratic anymore, it'd be a linear. Okay, so we're going to set a to not be 0. That way we're still dealing with a quadratic equation. All right, so those are just numbers. So it could just be like, I don't know, 3x squared plus 2x minus 1 equal to 0, right? That's a example of a quadratic with a equal to 3, b equal to 2, and c equal to -1, okay? So what I'm going to use to help me with factoring is the zero factor property. Okay, zero factor property says this: if I have two numbers a and b multiplied together and the answer is 0, then that means a must be 0 or b must be 0. Okay, so a equals, so let me get that again, a equal to 0 or b equal to 0. Or means that it could be one and not the other. It could be the other and not the first one. Or it could be both of them are equal to 0, okay? So that's what or is telling us, all right? So, but one of them is 0. And if you think about it, you have, 5 times something is equal to 0. That something there has to be 0. Okay, and the same thing if I have 0 times something equals 0. Well, I don't care what that number is, it's gonna be, the final answer is 0, right? I mean, that number could be 5 and it's still 0. Heck, that number could also be 0, and 0 times 0 is still 0. So that's the idea, okay? So let's solve by factoring. So I've got an example, x squared plus 6x minus 27 equals 0. Okay, now, when I solve by factoring, I want it set equal to 0 so I can use the zero factor property. It's already there, okay, so I didn't have to move anything over. And I think to myself, trinomial, I should think t-chart. AC method, multiply the first and the last. 1 times -27 is -27. And I want to add to 6. So 27, 9 times 3, I guess that's it, huh? 1 and 27, right? Now, one of them needs to be positive, one of them needs to be negative. If 9 is negative, that's -9 plus 3 is a -6. But if I make 3 negative, then that's -3 plus 9 gets me 6. And that is what I want, people. So my answer, my -3 and 9 are the factors. So what do? This is how I divvy up the 6x. I divvy up, so I make this turn into -3x plus 9x, right? So that's how I divvy that up. Now we can't forget about the first part, that's x squared and then minus 27, right? So I have x squared minus 3x plus 9x minus 27 all equal to 0. If I have 4 terms, I factor by grouping. I'm going to group the first 2, group the second 2, make sure there's a plus in the middle. What's in common between the 2? There's an x in both of those, so I'm going to factor an x out. And then what do I have left inside? Well, that's x minus 3, okay? And then over here, what do I have in common? Looks like a factor of 3, so I'm going to pull a positive 3 out. And then what do I have left? I've got a 3x and then minus 9. That doesn't match that, but guess what, guys? It's close. I didn't pull enough out here, did I? Okay, so if you don't quite get it right the first time, that's okay. Just keep trying. something I can take more than 3, I can actually take a 9 out, right? Because 9 goes into 27 evenly. So a 9, positive 9 comes out, and now I get x and then minus 3 here. And bingo, this is what we were looking for. We were looking for the same factor here as right here. And now I can factor that out. The x minus 3 comes out of both of those, and it leaves an x, and it also leaves a plus 9. And so this, my friends, is all equal to 0. So this is my A, this is my B. A times B equal to 0 tells me either A equals 0 or B equals 0, right? So what do? I set each piece x minus 3 equal to 0 and 9x plus 9 equal to 0, okay? And so if I add 3, I get x equals 3. And then over here, if I minus 9, I get x equals negative 9. Just like that. And so then what I'm going to do, I'm going to put an or between these. Now, why did I use or, not and? Well, a number cannot be 3 and negative 9 at the same time. So this is an or statement going on here. So those are my two solutions. So if you wanted to write out the solution set in curly bracket notation, 3 comma negative 9, just like that, and then close it up. That's your solution set. Okay? Cool. Let's try another one. Let's do, now this is a very common one people mess up. 3x squared minus 7x equals 0. Okay, how many terms is it? 1, 2, 2. Okay, it's 2 terms, right? So it's not trinomial factoring, so I don't do the AC method. Now, first step in factoring, always, first step, people always forget this. Don't forget it. First step, step 1. GCF. GCF. I promise you somebody's going to forget this. Do not forget GCF first. I factor out an x out of both of those. If I factor an x out of each of these, what do I have left inside? I've got 3x and then minus 7. Okay? And then the rest, this is equal to 0. So I'm going to set each piece equal to 0. X equals 0 and 3x minus 7 equals 0. So this is already solved. This one, if I add 7, I get 3x equals 7. Divide by 3, I get x equals 7/3. So those are my two solutions. So my solution set 0, comma 7/3. Close your bracket. Booyah. All right, let's do another. Okay, try this one out. 2x squared minus 3x equals x squared plus 18. Plus 18. Huh. What are we going to do? What is different about this problem? Well, we don't have it some blah, blah, blah equal to 0, right? So how do we make it blah, blah, blah equal to 0? Well, all I got to do is pick one side to move all my stuff to. So I'm going to move my squared term and my constant term. So I'm going to move the x squared and I'm going to move the constant term. If I do something on one side, got to do it to the other side, right? Now, why did I move this one and not that one, right? That might be a question you're asking. Well, I'm trying to avoid having a negative coefficient. So 2 minus 1 gets me 1 positive x squared. And then I have a minus 3x and a minus 18 equals, and then I got 0. Okay, so I'm trying to make sure that that coefficient in front is a positive coefficient. Now I'll have 3 terms, because it helps me, you know, later on with my factoring. 3 terms, trinomial, t-chart. I want it to multiply to 1 times negative 18 is negative 18. And then add to negative 3, so negative 3. So how do I do that? Well, 18 times 1, that's going to add to negative 17. That didn't work. 9 and 2, that's a negative 9 plus 2 is negative 7. We're getting closer. 6 and 3, if I make the 6 negative, negative 6 plus 3 gets me a negative 3. Bingo, this is what I want right there. That's what I'm looking for. So those are my numbers I'm going to split this piece up into. So I have x squared, and then this gets split up, right? It gets split up into a minus 6x and a plus 3x, and then a minus 18 equal to 0. So now that I have 4 terms, I'm going to factor by grouping. I'm going to group the first two, group the second two, make sure there's a plus in the middle. We're good. If you didn't have a plus in the middle, you just move the parentheses over and then put it in there, right? If it was a negative. Okay. Factor out an x from both pieces. I got x minus 6. Over here, if I factor 3 out, I get plus 3. And then, once again, x minus 6. Bingo. This is good for us because those match, right? So I have x minus 6 multiplied by x plus 3. And this is equal to 0. So I use the zero factor property, set each piece equal to 0, each factor equal to 0, and solve. And what do I get? I get x equals 6 or x equals negative 3. Yay, right? No biggie. Okay. Let's try another one. 4x squared minus 9 equals 0. 4x squared minus 9 equal to 0. Okay, so I want to factor. I want to solve by factoring. All right, solving by factoring. How do I do this? Well, to solve by factoring, I first look at say, okay, 2 terms, GCF. Is there anything in common between those two? 4 and 9. 4 and 9, one's odd, one's even. Doesn't look like that's going to work. One has a variable, one doesn't. So there's nothing in common. GCF is just 1. Okay. 2 terms is going to be difference or sum of cubes. Well, if I see the negative here, that tells me it's a difference of squares. Okay, so it's a difference of squares. How do I know it's squares? I mean, square root of 4 is 2, right? Square root of 9 is 3. Those are perfect squares. How about that? That's pretty nice. So what do I do for difference of squares? I take the square root of both individual pieces. And so the square root of this is 2x, and the square root of that is 3. So this factors to 2x plus 3 times 2x minus 3, okay? And now that I have that factored, that's a difference of squares. See, you know, difference of squares is really not that hard to do, right? It's pretty easy to do if you know what to do, when to do it, right? That's the problem I see on the exam. People, they just get to this point and they think, oh man, what do I even do to get the answer, right? So set it 2x plus 3 equal to 0, and then 2x minus 3 equal to 0. And if I solve for x, I'm going to subtract 3 from both sides here, and I get 2x equals negative 3. And so x is negative 3 over 2. Or, and if over here, I'm going to add 3. And so I get what? I get 2x equals 3, and then I divide by 2, and I get x equals 3 over 2. Okay? So those are my 2 solutions. So my solution set is negative 3 over 2, comma 3 over 2. Close it up. That's the solution set right there. 2 answers, plus or minus. Now, sometimes people, they might write it like this. X equals plus or minus 3 over 2. So this means the same thing. Okay, so if you wrote that, I'd give you credit for that, okay? Now, your homework system may not like that, but, you know, they're just a little picky, aren't they? All right. One last problem here for solving by factoring. I have 9x minus 5x squared equals negative 2. Okay, now, if you're going to solve by factoring, guys, the first thing you got to do to solve by factoring. Okay? Make sure it's something set equal to 0. That's the first thing. Make sure it's something set equal to 0. Then factor. Okay? Then factor. Okay? Now, I also want to make my a term so that ax squared plus bx plus c equal to 0. If I'm dealing with a quadratic equation, I would like a to be positive. Okay? So those are the two things. I want it to be set equal to 0, and I want a to be positive. That's what I want whenever I'm solving by factoring. This is a good step, good habit to get in. Right now, when I look at this problem, a is negative. How do I make a negative? Okay, how do I fix this? Attitude here, well, the inverse of minus is plus, so I'm going to add 5x squared to both sides. And so now I have 9x equals 5x squared minus 2. Okay, well, it's not, this is good, but it's not quite equal to 0. To make it equal to 0, I'm going to subtract 9x from both sides, and that gets me 0 equals 5x squared minus 9x minus 2. Okay? So, AC method, I need to multiply first and the last together. What do I get? I get negative 10 and add to 9. Oh my goodness. Well, 10 times 1 gets me 10, but that I need negative. So if I make that negative 10 and then plus 1, that gets me negative 9. Bingo, that's what I wanted. Okay, so this needs to be 5x squared and then plus 1x and then minus 10x and then minus 2, all equal to 0. Now, I wrote it in this order to help you out because remember, when I group it, what do I have to have in the middle? I have to have a plus. Right now there's a minus. So how do I fix that minus being in the middle? I'm going to eliminate that parentheses, and I'm going to put it inside the parentheses there, and then I'm going to add my plus in the middle there. Okay? And now I'm good to go. What comes out of both of those? I can pull an x out of both. And so if I pull an x out of both, I have 5x minus or plus 1. And then here, what can I pull out? Well, I want it to look like 5x, right? What do I pull out a negative 10 to make it 5? I pull a negative 2 out, and I think that's going to get it. So I pull a negative 2 out, and that gives me negative and a negative make a positive. 10 divided by 2 is 5. So that's my 5x, and then negative and negative. Okay, that's 1. So now I'm cooking with peanut oil. I see that those two things are the same. So I have 5x plus 1 factored out. And what does that leave me with? That leaves me with an x and a minus 2 right there. So I set each piece equal to 0. 5x plus 1 equals 0. And x minus 2 equals 0. And I solve and I get x equals negative 1/5 or x equals 2. Okay, so my solution set, negative 1/5 and 2. How about that? Not too bad, huh? All right, guys. Well, good luck going through and solving these quadratic equations by factoring.